Picking up, this is the second part of the Chapter 9 review. We're picking up with problem number 4, which I've copied over onto another sheet. We have a rhombus. They want the perimeter if those two lengths are what they gave here. I didn't draw the world's best picture, but a rhombus has 4 congruent sides, so we just need one side length, and we can multiply by 4. Rhombuses have diagonals that are perpendicular bisectors, so these are cutting each other in half, and they're perpendicular. So that means if, let's see here, BE is 8. So that means if this is 8 and this is 6, this is also going to be 6. This little 3, 4, 5 triangle, a 6, 8, 10 triangle, a 3, 4, 5 multiplied by 2. And so each of the sides will be 10, and that means that the perimeter is going to be 40 units. All right. Number 7, we have a ladder. It's 25 feet long. Touches 24 feet off the ground. We want to know how far the base is from the wall. Well, you could do the Pythagorean theorem, or if you know that that is a 7, 24, 25 triangle, you could do it really quickly. Question 8 says, find in the nearest tenth the altitude to the base of an isosceles triangle whose sides have length of 8, 6, and 8. Well, if the isosceles, that means that we have these sides here. I can break into 2 congruent triangles by dropping an altitude. So this is going to be 3, and then we're trying to find the altitude, which I'll label as x. That's not a triple, so we're going to have to do 3 squared plus x squared is equal to 8 squared. It's going to be 9 plus x squared is equal to 64. We can subtract 9 on both sides. We're going to get x squared is equal to 55, and that means x is going to be the square root of 55. And that is all that is going on in number 8. Oh, actually, it's not. They said to nearest tenth. 55 doesn't break down, so we can do radical 55 here. And tenths place is 1 decimal place, so that's going to be about 7.4 units. All right. What do we have after 8? We have 9. Question 9 says the length of the altitude of an equilateral triangle is 8 radical 3. We want to find the perimeter. So I have this little 30, 60, 90 triangle here. So 8 got multiplied by radical 3 to be 8 radical 3. And that means each of the sides is 16 units. 16 times 3 is 48 units for the perimeter. Number 10, they want you to find the length of the diagonal of a 2 by 5 rectangle. So a little Pythagorean theorem here. 2 squared plus 5 squared is equal to c squared, or you could do x or something like that. You're going to get 4 plus 25 is equal to c squared. Then you can take the square root, end up getting the square root of 29. All right, number 11. They give us a couple measures there. We have a 9, 11, and a 13. It's a trapezoid, not necessarily isosceles. And they want the length of RS. So I'm going to drop an altitude in here. This is also going to be 9 to get a right angle there. If this is 11, this is a rectangle. This would be 11, and this would be 2 to add up to 13. We're looking for the length of RS, so it looks like it's going to be 9 squared plus 2 squared is equal to the length of RS squared, which is going to be 81 plus 4 is equal to RS squared. And that means that RS is going to be the square root of 85. So radical 85 is our length there. All right, question 11 is followed by 12. We have an isosceles trapezoid. TX is 8, WV is 12. We have a 30-degree angle. They want TV and TZ. So we have all of that here. Once again, I can make a rectangle here. If this is 8, that's going to be 8. If this whole side is 12, that's going to leave me with 2 and 2 left over for each of these pieces to get to 12. And it's a little 30, 60, 90 triangle. It's turned on its side. Really, this triangle should look more like, should really look more kind of like that. And anyway, if you go back and look, we know that this side is 2. And this is the long leg, so you can divide by radical 3. You get 2 over radical 3. If I want to rationalize 2 over radical 3, I'm going to have to multiply the top and the bottom by radical 3. We end up with 2 radical 3 over 3, okay, which is going to be the length here, 2 radical 3 over 3. You double it to find the length of TV. So 2 radical 3 over 3. If you double it, doubling something is multiplying by 2. 2 is a fraction, is 2 over 1. So the numerator is getting multiplied by 2. We end up with 4 radical 3 on top, and on the bottom, we end up with 3, and that is our missing side length. All right? Question 14. Give you the square pyramid. They want the perimeter of the base. We have all that information right there. All right, so let's look at our diagram here. PR is 20, and let's see, my diagram here, R is right here. So PR is 20, that's going to be the altitude. PS is 25. Remember, you can make a little right triangle there, and I think this is a triple. These are both divisible by 5. That would be 5, that would be 4, this would be 3. So it's a 3, 4, 5 triangle that has been multiplied by 5. So that's going to be 15. This is going to the middle of a side, so side MK would be twice as long, which would be 30. They want the perimeter of the base. It's a 30 by 30, so the perimeter is going to be 120 units. And other lengths, is that really all they wanted on 14? Yeah, just the perimeter of JKMO. All right, well, there it is.